Right, welcome to another stream, everyone. How we doing? Just posted we're live. So, we're trying to get closer to get the engine into a place where we can start making a game, basically. I need to reveal what that game is still, but yeah, we're getting closer. So we've got this build system. It's all right. It's written from scratch in C, and you literally just do clang-o build script, build script.c, and then you do and build script .exe, and then it runs it, right? And then what's great about it, builds all the stuff, runs in the background, and if you change a file, it builds it. And then it tells the game, hey, you can hotcode reload. The game's like, sure, I've got it. And it hotcode reloads. So it's pretty cool. But it has some issues, so we're just sort of reworking it before we work on the game, because the assets cannot be hot reloaded yet because of the way it's been thrown together. So now it just needs a proper rework. But yeah, the build system builds assets and code. That's the plan. It's going to be cool. Yeah, so working on a DAG today, which I forget what that stands for, but it basically means a graph which doesn't loop around. And build systems use it so they can go to the top of the graph and launch the dependencies at the top. Sorry, the commands at the top without any dependencies, and then trickle down them, which is cool. So yeah, we're working on that today. Any questions, feel free to ask away. And yeah, let's start with a quick prayer. And we go. Father in heaven, we thank you, Lord, for this day. We bless your holy name. Thank you for being our great provider. Thank you for giving us all the things we have, the ease of life that we have in this day and age. Thank you for the peace in our land that we still have as well. And, looking around at where I live and maybe where other people live, compared to other places in the world, we're very blessed, even though it feels like our country is falling apart right now. But, we thank you, Lord, for the blessings that we have. And we thank you for the food on our table and, our families and everything like this who are still around. Father, I pray that you help me with this project, and we find the right direction, go in the right ways, and not waste any time on things which don't yield any fruit. And I just pray that for each and every one of these viewers that come by, they just get to know you more, Lord Jesus, and they receive the salvation through your grace, or by your grace, through faith in your sacrifice on the cross, and help them know that it's just a gift from God, not of works. So we don't earn our salvation, it's all a gift from you. And I pray that these viewers, when they come by, they one day encounter that gospel and they receive their free gift of salvation by their faith in you doing the work fully for them. And I just pray that you help draw them in, Holy Father, and such that they're not damned to hell when they're finished with this their time on earth. And Lord, I also pray for their families as well, and for themselves, that if anyone's going through a tough time, that you help them with their tough time they're going through, and allow it so they don't get destroyed by the enemy. Thank you, Lord. In Jesus' name we pray. Amen. Righty-o. That's all good. Yeah. Lovely. So, the build system, I'm currently reworking it. And we're reworking it by just simply doing this if and then writing the new code in here. Ta-da! But it's quite simple. So I've got a function which indexes the file system. I've got another function which does the filter. Now it's time to build the DAG. So a DAG is a directed acyclic graph. So basically it's a graph which doesn't go round, and you can find at what order to execute execute nodes, and you can execute nodes in parallel, and when a node is finished, you know which ones to execute next, basically. So quite simple, really. It's just a graph. That's what we mean by a DAG. So the current design is, it literally, you just initialize commands, but you can put down barriers as well. So every single time you change your file, it goes down this in order and then checks the timestamps, I think, and then it will rebuild the ones which need changing. Which need rebuilding because they've changed, because the timestamps have changed. And as I said, you put barriers down, but this obviously has some problems where you have to maybe define everything manually, and if you have it as a graph, you could technically get a better you'll get a better things will be able to be parallelized far better, right? Because with a barrier, it's just one stream, and when you put a barrier down, you have to wait for all the previous stuff to be built. Whereas if you have a graph, technically you can have multiple streams of execution, if you will, right? Many different barriers going at the same time. So that's kind of why we're switching to a graph, because it makes the most sense. Now, effectively, we just want to rewrite this sort of code, right? How do we say, I want to compile all of these shaders inside this folder, right? But not having to say compile them all. Like, we want to be able to create a new node, which basically launches one process to compile each of these shaders, right? And when those are all done, yeah. So, yeah, sometimes you might want to have, though, compiling a DLL, you might want to take in a range of C files or a range of .o files, whichever one. And then you want to be able to basically have all of those execute one command, right? To compile the DLL or link it, shall we say. So there's a few different like types of node. One is just a single execution, another one is like multiple executions, but for a range of inputs. So I think we'll just start building and just see how we're going to do it, basically. So I think we can just get rid of this for now. That was the filter stuff. So what we want to try and do, I guess we can build some of the data, because it's always good to start with the data first. So just call it DAG node. Maybe that's the way we start. Then we probably want to have a DAG graph maybe as well. But then the G means graph, so it's just DAG. So you probably have your nodes in here. And you probably have a nodes cap sitting somewhere, right? This is how I get away with lots of things. I just max allocate it, which is all right just for this simple build thing. So let's say there's 1,000. You know, we can easily just say 8,000. We need to make it higher, we can make it higher. Cool. So essentially a node is going to be like a command, maybe. So we'll just have a command that we're pointing to. Let's just get rid of the const, because yeah, it doesn't really matter. So the command we're going to run, maybe the command, yeah, we'll think about that. Maybe it's going to be like a pattern thing, you know, that gets replaced with some variables or whatever, but we'll see. You're obviously going to have some form of dependencies, right? So technically you could probably get away with only yeah, I think maybe you should have a yeah, so we could do like a linked list of these nodes. So maybe we have to have a thing called a dep. So a dependency is just going to be a node, and then it will maybe point to the next dependency. So it's like a linked list, right? Equally though, we could just do a growable array inside the node itself, and that is probably going to be better. Although you might have to do lots of reallocations and stuff, or you just max allocate, right? You can have a maximum number of dependencies, and then we just up that number. But yeah, you can get quite explosive allocation numbers if we did that, say. Yeah, I'm not usually a fan of linked lists though, but it should probably be fine. Let's just roll with it. So dependencies list head. So I can call that a dep list node, maybe, but right. So you have dependencies and dependers, right? So obviously the dependers are what this node is going to wait on before it runs, and a dependency is something which is going to tell, hey, I'm finished now. Dependencies, if you can go, go, right? And we probably want to have some kind of counter to just reduce, to say, to maybe say, yeah, maybe we'll need a counter on there. We'll see. But let's just build the node for the graph first. So we probably would like a function. I think we can safely move this now. So we're going to move it up to the build script.h file. And yeah, we just got a global structure called build. So there we go. Just call it DAG. So then build init. Let's initialize the bits. So DAG nodes a zero allocated thing, so it's DAG nodes cap size of DAG nodes, yeah, or the dereference of it. Cool. So the next thing is we would really like is a few functions for the DAG, right? So essentially we want to run a particular command, like, you know, compile shaders and stuff like that. So those will end up creating different DAG nodes. What would it create though? So yeah, let's have a think about this for a second. So say if we have a, man, Twitch is getting crazy with these things. Anyways, So we might have an input, right? Let's say the input is a file known as, right, let's just say we're compiling some C stuff. Let's do the super long-winded one, right, where you would say, right, a file called game.c, and this is going to then output game.h, .o, and then but the command it needs to run is clang something, right? So then you will have another node, if you will, which has an input of game.o and maybe some other ones, right? And then that's going to end up building out game.exe. And that's again some different kind of clang command, or maybe like some different linker, right? But there we go. Then so it's essentially like what is so you could probably imagine a node. Yeah, so what are the nodes exactly? Are we gonna say the outputs are a node, but technically you could probably output multiple things, right? Let's just say like sometimes, you know, technically there's a game dot d file, right, which will describe all the or maybe game.d would be here, right? There's two output files, right? So and there can actually be technically be different multiple inputs as well. So this is kind of a node with a command, right? With different inputs and outputs. So these are dependencies. And then in order to build, say if you wanted to say, right, build everything up until game.d, then game.d, I guess, has a dependency on this command node, right? Being ran. So maybe there's different types of nodes, right? Maybe there's each of these are nodes. Yeah, so maybe you can have like in this tree, you have files and then you have commands, and commands take in and output files. Yeah, I think that's maybe what we're kind of looking for with this sort of tree thing. But right, so build script.h, we'll go back to here again. Now we've thought about it a bit more, and needs a bit of a change. It's kind of close though. So a node has inputs and outputs. I haven't got my drink up here. I need to go and get that. Each file is its own. Yeah, so say if you're like, right, I've done building this command. How do we pass? How does this one then get triggered? So the dependency would be, do you just tell the game.o file? Yeah, you tell the game.o file like it's node that it's done. It's been built. And you look at all the things which are depending on that file. Right, so right. So I think then you'll have a DAG command node and a DAG file node, I think. That's what you'll do. I think that's the way it works. So the file will simply store, obviously it's like path, but then also the commands that it is going to, right, so these definitely dependency, right, command node, but then there's only one thing that can build this file, right? There's either it nothing builds it because it's kind of like source code or whatever, a source asset, or maybe it gets built, so therefore so this would be the creation command node, if that's what you want to call it. Okay, so that's interesting. Now you've got this thing called a command node. And again, this could probably be like a pattern, maybe with some variables, not sure. So this one's going to have a bunch of inputs and outputs. So I guess you can call this a command dep, and maybe there can also be a file dep. So that links to a file node, and then you can also point to the next file dep and the next command dep. So a command is going to house two streams of file deps, dependencies, right? So that'll be inputs and outputs. And obviously the inputs are dependers, and outputs are dependencies. Yeah, I wonder if you really want to call it like, yeah, these are output. Yeah, I think that's right. So then, right, there's two different types of nodes. Yeah. We could just have one big type, but with like a union or whatever, but I think this is fine. I spelled that wrong. Cool. Right, so you have file nodes, and you also have command nodes. Right, it's a bit better now. So we just have a nodes cap still, and voila. So I think really you'd actually need more files or whatever, so it might just be better to do that. So you'll probably have 1,000 commands, but 8 times the number of files, something like that, yeah? So, right, where was we? So let's go to the build init, and let's just correct that, and then we can start writing the lovely functions. So, all right. Now, what we're looking for is ways to create nodes and stuff, right? So I guess I could put it with these, really. No, on DAG. Or... yeah, really DAG should be like in its own thing. It'd be realistic. So like, yeah, one of these guys. All right, now I reckon it should go before the commands because the commands are actually going to use it. Okay. And then we'll have some functions. So we say, right, DAG file. No, so I guess, right, you'll come across a new file and, or like a string, and you basically want to like deduplicate and get a node, right? So we'll probably need a hash table as well. So we can throw together one of those. Yeah. DAG file node dedupe. So you'll just have a char which gets thrown in there for a path, and it'll give you a file node back out, right? And obviously be empty. Yeah, so if yeah, that's interesting. So if something yeah, so if you're the command to make it, so say if you're calling like the linker and you output an exe, you create a new file node for that exe, but if something else has already made it and set the creation command node, then obviously that's two things trying to output the same file node. So yeah, I think that's fine. We should probably have a way to set a set function for that or something. Maybe, I don't know. Anyways, thinking a bit ahead there, but that's fine. So we want to also be able to create a command node as well. So with a command node, I don't think we're really saying like dedupe actually. I think for a command node, what we're saying is initialize. And yeah, that's what we're saying, right? Is initialize. Now, we can then do an add input maybe. Input add. So command and file. Output. Right, let's do that. What else? So with a file, you might want to probably set. Oh, whoops. You might want to set the creation command. And you might also want to add a dependency. Yeah, so one's like a... Anyway, yeah, I think that's fine. So, nice. Awesome. Now, one more thing. Yeah, we can start implementing these, but because we have a file node, we kind of need a hash table. Like, you could probably just like do a super terrible array loop or whatever, but yeah, you probably want a hash table. So, I haven't got a hash table for this in this project yet. I have got one in my engine. I could copy paste that. But equally, I think we could just jam one in, which is a bit generic, I think. So one which takes string keys, and it gives you an index maybe. And that way it have to be template or anything like that. Or we can hold a void pointer somewhere. Yeah, no, yeah, I think we can do one. You know what, I've actually got one, exactly one of these, in another personal project of mine, but I don't really want to reveal it because it's secret stuff. Yeah, let me go fish that out and then paste it in my code base. Yeah, I'll put a secret screen. Can I do that? Okay, the secret stuff is over. So here it is. I just pasted the code here. So we need to take this and put it in. Oh, this is in the header file. Lovely. Right, so we probably need a string as well. Let's get one of these. So we've just got a thing called hash table. Hash table entry is a string key and then a void pointer for the value, right? So that way it's generic enough. And we probably always want to have things as string keys when we do hash tables for this project, maybe. We'll see. If we need something else, we'll sort it out, but I think this will be fine for now. So here's the platform stuff. Got your pointer as well, lovely. All right, so okay, so we need like a string equal thing. There's like we need some of these things. Round up how to. Let's get that in there. So I've got a thing called alloc zeroed. Anyways, we'll this is in a header file. We'll quickly just get these functions here. And move it into source code. Alright. Here we go. Okay, we need a new function. For string equality, or probably a macro, it'd be quite easy. But yeah, this one is alloc zeroed. So size of this multiplied by the capacity alloc zeroed size of this multiplied by capacity. All right. So where this is defined in the header file, they want string equality, so that is just going to be A and B. So something like A dot size equal B dot size and mem compare A dot data B dot data A dot size. Now the very important bit equals 0. Lovely. So that should get us our hash table. Just a very basic one. Does the job. It's better than searching for an array. Oh, semicolon. Oh, crap. I need to get one of these as well. In the platform section somewhere. Okay, so I think that hash table's there now. Can't see it, but HT. There we go, this is it. Of course, there's no compile errors there now. Amazing. So, back to the build script.h. In the DAG, we would like to put in a hash table now. Hash table, and this is just going to be called like file hash table or file map, right? Or path to file map, or maybe file from path map. There we go. So when we initialize, so we're going to do ht in it, the address of g build dag this thing, and the capacity is just going to be the number of nodes, yeah? And voila. So now we can finally build those functions. So these guys for the DAG. So it's underneath command basically. All these guys. Underneath command. Oh, above command, sorry. Yeah. Here we go. So nice. So these are the guys to implement. So we want to have a way to like, right. We're back from a minute. I just want to get my drink, getting thirsty. BRB. But any questions, feel free to ask away. I'll just do this. Hello, welcome back. All right, just got myself that drink now. Oh. So, basically we bump allocate a node. Right, I think I got something where I say count plus equal 1 plus I got backslash. Here we go. Right, so stuff like these, right? I should have really added my dynamic array into this code base, but I haven't, so I'm back to old school C without stuff, right? So I'm just doing things like this still, but anyway, fine. Let's just do it. So DAG file nodes count. Yeah, so we get an insert index. We we bounds check it, right? So now it's safe. Like Rust jokes. Yeah, it's really great since AI has come around. Now no one talks about Rust. Like you should program in Rust. It's like complete silent. Amazing. But now everyone talks about AI instead. So yeah. Yeah, you replace one thing with another. DAG.file nodes. DAG file node. There it is. N. Pow, 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 pow. Lovely. All it took was 4 lines, right? Now, you don't always want to do this. So the next thing is we want to use the hash tables. HT, find or insert. So G build DAG. Now I'm probably better off getting the DAG here. So just call it D. And then more realistically, that's better. Now we're just saying DAG file from path hash tables to the string C path. The value we're going to default it to would be nothing. Yeah. Right, we need to sort that out. I think we need to change that function to work a bit differently, but so oh no, it still returns the value that we can. Oh yeah, it's cool. So yeah, that we can mutate. So what are we saying? So value pointer. Not sure what's happening here. Oh, of course, semicolon. Damn it. Right, let's fix that. Nice. So if it's new, so it's no longer, it's not been, made yet. We simply just make a node, fill in all the bits, so path equal path. Then obviously these are equal to null. It is already zeroed actually, so I think we don't have to set those. Zeroed memory, isn't that right? Yeah, but equally. All right. Okay. Wait, it's zeroed memory, isn't it? Yeah, we never wipe those. Cool. So then value pointer equal. So we put it in the hash table. Right. So then at the end we simply just deref value pointer and voila. That's a deduplicated file node. Now the next thing we want to do is do this sort of set. So all this set is going to do is this, but it's going to have some safety. So if it's already set, so I guess you're just doing a assert, right? Can we file node equal null, right? Not set, please. And so we'll just say file node this guy already has a creation command of this guy, but trying to set to command this one. Nice. So we'll just say something like file path, file creation node command, and then command. Yeah. Ain't that good. Alright, so we'll call that in different what will we call that in there? We'll call that in when we're making different like commands, I think. That sort of thing. Anyway, we'll find out. Or maybe we'll put it in the add input and output, I think. Or maybe it only gets put on add output. Yeah, when you add an output, that's the only time it'll get. Yeah, so maybe we don't need this function, but we'll need the contents, that's for sure. If we need to put it back into that function, we'll just make it again, yeah? So add dependency. So dependency is going to be exactly like this code. Bearing in mind, we haven't got an array of dependencies yet. So we could do alloc zeroed or whatever, but that would be kind of dumb. I don't have like a bump allocator, so we'll make these bump allocators. Well, we could have a pool of memory that we. Yeah, we should replace malloc. It's kind of dumb. So I do alloc zeroed, right? And this is just malloc, right? Because I was just being lazy. But let's just do it properly, right? It really isn't that difficult. So like, literally for the build system, let's just have a pool of memory, right? That's all the memory. And when we init, we'll just do the Windows way of doing it, right? Virtual alloc. So you'll have like, I think you have like a mem capacity. So let's do something reasonable. I guess we could say, let's just say 8 megabytes. That ought to be good enough. Then if we reach it, we just up the number, right? So in build init, literally all we do is virtual alloc null mem capacity mem commit, I think it is, mem reserve mem commit, if I remember correctly. Then the protection, yeah, forget these things. Let me see how we do it. Page execute. So page read write. Yeah. Cool. So simply we'll just do gbuild.mem and voila. So we'll just do an assert. Failed to allocate, or the virtual alloc failed, and then just some code. So get last error from Windows, right? Ought to be good enough, yeah. So I think that'll do us. Now all we're looking at doing is putting a U pointer in there for some kind of like mem size. Now we just need the bump alloc code, so it's all pretty easy from here on out. We're just going to do a simple bump allocator. So alloc zeroed, I don't think that exists in the header file. So we'll just put it in here. So we just say, so it's all zeroed by default. So we just say alloc. So alloc, what you're looking for is a size and maybe some alignment, right? And then what you also kind of want is some macros where you can say like alloc array of t and a count, right? It's a very popular one. So you just do alloc size of t times count, and then a line of t. Yeah. Then you probably also want to be able to allocate like a single element as well. That's also quite a nice one. And we don't worry about the deallocation side of things. Let's keep on allocating and job done. So with that, we can just make this guy. Now, I need that round up. So this is the little, how you do a round up a line. So you want to take your size, or do we care if size is a line? Yes, you want to take the current cursor, so g build mem size, or maybe call it mem cursor. I think that's probably a better name. And you'll run up to a line. So there's your new cursor. Now all we're going to try and say is assert that cursor plus size is less than the mem capacity, if not out of memory over, this many bytes reached maximum allocation of this many bytes, right? Nice. Cool, so we basically just, commit the mem cursor. But we want to then like return. Do we have like a pointer add? I don't think we do. Let's put that in there as well. So it's nice. Ought to be good enough. Now, so yeah, super cheap allocation basically, so we can do those really small single type nodes and stuff without having to keep. So those linked list nodes can just call this and it'll be completely fine. Yeah. So I need that function. Sorry, macro. This guy. Bit messy, but there we go. Rightio. So back to where we were. So it was doing the sort of DAG node stuff. Right, so I wanted to make a dependency node and all this and sorry, there's all that alloc zeroed stuff. Let me sort that out quick. Let's get rid of malloc, completely get rid of it, it's horrible. It's the most silly thing ever. So now we can just call our new lovely function called alloc array. Right, we pass in the t and that's it, right? So just want to change the few places where I do this. So there's nothing called a line of. We need to sort that out. I think that's right. Anyway. Let's type in. Okay. Cool. So anything else with malloc like floating around? This thing. A line of pointer might be probably best. Alloc. I just remembered actually. This is alloc array. WCHART. This alloc array thing should cast to T. The reason being, because then it will be type checked pointer. Alright. Ooh. Yeah, so these ones we're going to be getting rid of anyway. This one we're not there. Wow. alloc array handle. Yeah, we need to look at this code again very, very soon. Right, this is the final one, so I guess we can just say alloc and leave it at that. Alright, cool. So that's all the mallocs gone. Anyway, where was we? So I was looking. Oh. Yeah. So making a dependency. So now we can literally just do this. Right, alloc element, pass in the T. So we want to allocate a new dependency node. So DAG dep who, what is this going to be called? So this is a command dependency. So we just call it dep. We probably want to get the DAG. Yep. Or maybe we don't. But yeah, so we're looking at basically saying, right, dep node is equal to command. And the next is obviously null, but we don't have to set that. Then we just set file dependency list head is equal to dep, but actually, sorry, dep.next. Right, this is the linked list insert. There we go. Cool. So, to make a new to replace file with command. Nearly that. And we initialize it with the command, whatever that means in the end, probably has replaceable stuff in that string, I'm not sure yet. And so a command can have an input and an output on the file. So we do a what's known as a file dependency. Slightly different node. So that links to a file node. And on the command, there'll be an input. Right, so inputs list head. Bit of a better name. And there we go. Now for the outputs, very nearly done now. So for the outputs, there's a creation node. Oh, hang on a minute. DAG file node. Add dependency, is that right? Yeah, so maybe you don't even need this add dependency thing as well. Interesting. Like, because when you add an input or an output, it will automatically put dependencies on the file, I think. Yeah, I think this is the only use case for it. So maybe we can just wrap these guys in scope blocks. Cool. So when we add an output, we just need to rather than the inputs linked list, we go on the outputs linked list. And then change the file node such that it knows which command created it, yeah? Cool. So there's only one more thing I would want to sort of think about when it comes to these DAG functions, and now we can just start using them basically and building this DAG by just saying, right, I've got some commands I want to initialize, like the, one for Clang, right, one for the shader compiler and stuff like this, right? So I'm thinking like, so outputs, what happens if you define this? Is it possible to define the same inputs and outputs multiple times? And is that a problem? Right, say if we had a game.c input and that made a game.o output. So if you defined game.c twice, well, it's going to deduplicate and have the same input. I don't think that's going to cause too much of a problem. And then if you had the same output, two files the same. Yeah, I think it can be problematic. I think what would be better is maybe if we don't, like, we should probably catch problems like that, I think. Yeah, we should probably catch problems like that. So we probably want to like so we can probably just make a little stag function. DAG file dep assert unique okay. So while dep equal dep next, right? And then if so core assert dep node not equal file, right? So now we basically say, right, found. Now, and maybe we'll have like a command as well, right in there, so we can just say found duplicate, and we'll have a char called what? Found duplicate one of these guys. So it would be duplicate input or duplicate output on command this guy. File this guy. It's a file path command, yeah. Basically it. We'll need a what in there as well. Yeah. Okay, so just some kind of assert unique. Now, that'll go here. So, dependency, so command inputs head, command file input, yeah. Yeah. Right, so this is everything we need now. So this commands stuff. I want to change this stuff I basically want to get rid of now. I do not know. Yeah, so this is, it used to just be a list that we used to just execute. Can't do that anymore. So I think we'll retouch on that because we just spent a bit doing a hash table, custom allocator, like pump allocator, and the DAG node stuff. So that's all done now. Now we can move on to the actual commands. So I'm thinking, so yeah, the system used to just be, hey, it's just a list of commands to execute, and you can put barriers down, right? There was no dependencies or inputs really. You just basically gave it what you wanted to compile and put a barrier down when you needed a barrier. The barrier would basically say, right, wait for all this stuff to finish beforehand before you start running these commands. So this will be a list of commands, and when a file changed on the file system, it would be like, right, these files changed. So now what I need to do is go down this list in order again and run the commands which inputs have changed, right? And that's all it would do. It's done as well, but we've had to manually define the files and various things. So effectively what we want to do now is make a DAG, right? So just a node graph basically. So the downside about doing like a barrier-based approach is you would have to drain until no threads are running any commands. Whereas with a tree, you can end up in multiple streams of execution technically, which are going at the same time. And sorry, streams of like is a tree, right? So there's many different barriers on different nodes, right? So many different streams of node being executed at the same time. So the thing that we need to be able to do is we might, for these shaders, these, compile these shaders, right? We want this to maybe be a single node, but then it wants to spawn many commands, right? On, yes, but spawn many commands. And that way we don't create tons of different nodes. No. Okay. Yeah, I think we want to have a way. Now this function is going to create tons of nodes. Yeah. Yeah, I think that's the way we'll do it. Or we could have a different node type. Yeah, there's two different ways we can do it. So basically, if I write this down in a comment, it'll make more sense. So essentially, you can have tons of different input files, right? You can have like graphics in it. So this just initializes the GPU system. It's a compute shader. And you have like a graphics frame in it, which initializes the memory on the GPU for at the beginning of every frame. These are two separate shaders. You don't actually need, like, as soon as one file is ready, it should get compiled. It shouldn't have to wait for all of the inputs to be ready to run the command. So the output is obviously just going to be a SPV file, yeah? So I think it's SPV, but whatever. Now, the command that's going to run, I think it's like glslc, something like that. It's one of these many terrible compilers. And it does the whole, it you probably want to take right, some kind of variable out, right? Let's just say that. And it's a variable in, yeah? Now, it's obviously got other arguments, but you get the idea. Now, we could say this command node is in some kind of one-to-one mode, right? So you make one node, and the idea is this is a many command. We can call it a many command, and we can call another one a singular command. But so for every input, there's one output type of thing. Maybe. Hey there, Cellophane. Which compiler is the most terrible? You did a DAG for your build system. Yeah, yeah, we're just written the DAG thing. I think it's DAG. I've not run a DAG before, but I get the gist of what it is. So yeah, we got all the functions for it now. We just literally spent the start of the stream doing this. Never seen one do that. You sure build systems don't use DAGs? Pretty sure they do. Because you got to solve the dependencies, right? And a DAG is a good way to do it. I'm pretty sure if you look into Ninja, it probably does it, right? I've not looked at the Ninja source code though. It's quite a simple concept, right? It's just a graph. We gotta walk the graph as well, but there we go. But yeah, you can probably call this a one-to-one. So you can probably call this like the command type will be a one-to-one. So Ninja is so fast. I don't know. I like. Yeah, Ninja has. I've used Ninja for a bit. It's got some. Yeah, I'm not a fan of the custom format thing that it's got. But yeah, it's just. Yeah. I guess it is fast in comparison to other build systems, but yeah. What would be better is if it didn't have to pass a custom file, right? It just was C code, and that's what we're basically building. It, this, it is like 2,000 lines of code at the moment, but that's just because I've got, well, yeah, we'll be able to get rid of some of the stuff, I think. But anyways, shouldn't be too many more lines of code, I don't think. Yeah, command type. Yeah, so the basic idea is the whole graph is going to be like just written out in C code. So it just runs C code rather than parsing a file, opening a file and parsing it. So it should just be able to get up and running quite quick. What else? Yeah, this won't be a library though. Like I could make this into like a single header library you just include, but I can't be bothered to do that. But yeah, I could maybe do that in the future. But also then it means you have to support other people, so that's why I probably won't do it. So command type, we can call this like a one-to-one. Yeah, it's interesting, right? You can also have like, so what that means is for every one input, there's one output, right? And literally like that's the way the node works. There's one node that gets made in the DAG, and whenever the input becomes done or ready, it will then execute the command for that dependency. Sorry, when that file becomes ready to be executed, it will execute that command for that depender. And then when the dependency is done, it will mark it as done. But then you kind of have to have maybe like a bit set for every single command node to sort of know which one of the sub jobs are finished. Or you could just make a node for every single. Yeah, I think doing these different command types or node types are probably not that wise. You could just make one command and just allocate more memory and stuff. And maybe that's better. Otherwise you got all these different types of nodes. Yeah, let's just make a sea, whole sea of nodes, and see what happens. So yeah, let's just get started with that. So let's start off with this VK shader one, yeah? So essentially we just want to do another one of these. The VK command or just command VK shader. And so you're just taking a directory and like a shader name, right? So what we probably want is like some, I called it like a filter, didn't I, down here? This filter match. So rather than filter, should we call pattern, I think. We'll just call it filter is fine. Okay, so we probably want to move those filter functions and that somewhere else. Let's go to build script.h. I'm assuming the LSP could reuse the DAG. It's going to look for paths. I'm not sure you mean what the language server. I didn't know how it. Oh. Yeah, so basically what you would do is it's the other way around, right? So basically I'm going to be you call Clang, and I think you can do like a dry run mode where you can basically get it to give you give it the input file, it scans it and then gives you a list of dependencies. But that also kind of sucks. So another thing you could uh, do, which we're doing at the moment, is if there is no dependencies, you just compile it anyway. And then, oh no. Yeah, you probably have to do a dry run mode if there's no dependencies file to generate a dependencies file, and then use the last dependencies file that exists on disk. And these ones we just store inside the build. There's somewhere in here. It's a .d file. Something like that. Yeah, so basically it says like for this exe, it depends on this and then all these things. And so we can know that then to build this exe, we need to make sure all of these are available and ready, right? And not being built at the moment. So yeah, dependency files, you can get Clang to generate those. Quite nice. Cool. So we want a way to like find it's like the indexed the file index, I guess you'll call it. Right, so right, what we got here? So we wrote this stuff last stream, basically. Does the job, that's all I'm gonna say. I don't think we need this one's static. Does filter match? I think that'll do. Yeah, so we're looking. Okay. Right, so we've got the file index now. So when we do those commands, this is that command VK shader. So I think what we can take in is some kind of like filter of files that you want, basically. Input filter, we'll call it. And we can use search the index file system and retrieve a list of strings. So these are the inputs. Now the lovely thing is, you wonder why we're in size strings and not size strings everywhere, and everything is a bit silly. But yeah, there's that. So yeah, we probably want to be passing these shouldn't probably be char, this should probably just be the string type. Hang on. Okay, so that way we don't have to do a string length there. And voila. So back to the commands again. So we basically filter across the whole, the indexed list. It gives us a new array of inputs, which is nice. Now we probably want to have another function to do with actually finding, so given a path, you want to retrieve a I've got this in path file name, this sort of stuff, right? I wanna I really want these guys. These be very, very handy. So we'll go to where Okay, it's a path. Yeah. So, where's those other string functions that we're missing? Um, anyway, we're missing those. There's the slice ones as well, right? Oh, these guys. All right, here we go. So, right, let's replace that core. Okay, so these will go to the header file. Nice. Right, so you point a max, we need that. Hmm. Right, string null. We'll get that one in there as well. So define. Nice. All right. Getting closer. Like we could do a format macro as well, right? So string in string size, string data. I'll do it. All right. I didn't realize we had an alloc zeroed here. Well, I corrected that one. Yes, here we go. Oh, okay. Whoops. String format. Cool. So back to this VK shader, finally. So now I've turned everything into a string type. So the way it used to work is it would figure out what the shader stage is for GLSL C by checking the extension, right? Or the second extension or something like that. But yeah, so we've got, so if essentially we want to go over all of the inputs. Sorry, I've been dumb. And I think what we're looking at doing is making a node per input. It's just the way we're going to do it. It'll be cool. So we've got the size already. So shader name. So it'll be the imp. Yeah, I guess we'll call it shader name. Let's call it n. So n dot data or p for path. So p dot data plus p dot size. String format. Okay, so getting there. Right, so we pick that sort of stage string. We use this lovely function here to generate a command string. So the name, right, I think we want to do more of these dot stars again. Ugh, so many of these things. So dot star. Oh wait, this is interesting. So actually, yeah, shaders.d, build shaders. Okay, this is interesting. Yeah, so we need to build a couple of output paths from. Okay. So realistically then, string format, which we'll have to move, should actually return a string, right? This is cool. Very powerful. Oh, what happened there? Okay, so that's where the fun begins. So when we do we want to create one string, which will actually be the spivvy file, spivvy path. So that is this guy, and there'll be a dependency file path as well. So it's just a string format. There's your format string. Now I'm thinking like you want the file name here. So I think I called it path file name. There we go. So here you'll be doing a string format file name. And then you want to do another one for the dependency file, right? The dep file. So that goes in, it ends with a .d instead, yeah? Nice. And so these will actually go into here as a star, like that, instead, yeah? %.star s, nice. So let's go through this quickly. So you got the executable, boom. You got the debug flags, or whatever they are, right? So yeah, they'll pass in stuff for if it's debug or whatever in debug mode only. Then the shader stages from up here. Entry point is main, and then the flags. And now here is the dependency file path. The next one is the SpearV. There's this one here, the output. And then the final one is the full path to the file, input file. Ta-da! Okay. So what we find out is this is the command string. That we will want to run. So it makes a unique one of these for every single command, basically. So now this is where it goes into the DAG. Ready? Easy peasy. So we say DAG file node. So the SpearV file node. So DAG file node deduplicate SpearV file path. Then we want a dependencies file. We want a dependencies file. And then we also want a so DAG command init. So we want to get a DAG command node. So we get a command node. As we pass in the command string, which we just made. Then we say DAG command node add input command node. So the command node has, what file input are we doing? So the input is going to be, oh, we also want an input node. Yeah. So the input is obviously input file node. The output is SpearV file node, and another output is the dep file node. And yeah, I think that is basically our first yeah, that's our first node there, guys. Well done. Good job. Good job. Now, what I think will be cool is if we had a way to like maybe visualize some of this stuff. Like, because it's all well and good. Like we could dump the DAG to a file, but then equally that's like really difficult to look at. So I don't know if you guys know about this, but there's a thing called like graph viz. Have you seen it? Like that. You spell it like a cool kid with a Z. So what you can do, like it doesn't always produce the most nice looking graphs sometimes, but it's better than just trying to output. It's really easy just to output these files, and they do kind of work sometimes, right? So we're going to try this out because it's like really easy to do, right? So effectively, we just want a function which makes a graph viz dots file. So we just call DAG. We'll just make a function called DAG dump, and it's just going to dump the DAG to a file, right? Easy peasy. And that's what we'll do. It's just a text file, right? One line per node, and you send it to another program and you can visualize the whole graph. Very easy. Right, I'm just gonna fill up this drink and then we'll quickly throw that out and then we'll be able to visualize our DAG as we progress through this, which would be kind of cool. Right, BRB. Right, welcome back everyone. Right, so I think what you can do is, I guess we can just use file to dump this and just stream it directly to disk. So we're just doing F open. We'll do a write to a build DAG dot. Right, so it's a dots file it's called. And this we can just open this in the node, in a node viewer or whatever you call them. Super cool. So we simply just F write it in basically. So you can go over all the nodes, get yourself a DAG. We'll first do all the file nodes. So index 0 D file nodes. Get yourself a file node. File node is probably going to have the current working directory in there, but we can sort that out. So we'll say well, there's trim and stuff maybe. Anyway, DAG file node and the file nodes index, yeah. And all we're looking to do is fprintf, and then you follow the format. So what's the format? Well, it's quite simple basically. So yeah, you can do stuff like this, right? So we can have our files be circle. Maybe that's another thing we can do. Yeah, we don't need all this subgraph stuff. But yeah, so we'll do something like we probably want to put the commands in boxes, I think. Right, so you define the nodes and then you define the links. It seems like you can define. Yeah, so we should define the node. Okay, so we just define the nodes. You'll be like string shape equal circle, I guess. What shapes do you get? Obviously, it's the ellipse in it. Okay. New line. Okay. And we probably want to define a graph. Call it digraph. I don't think we need that, but let's just try it without. So we say n dot or string format n path, yeah. And for f, yeah. Okay. So we start off by just defining the types of nodes. And then we simply, this one is going to be a box. That'll be a, yeah, just a box, yeah. Now we just define all the links. We do it again, second time round. So the link will be, so you define the name and then the one with a new line at the end, yeah? So one's with a string and then a space and an arrow. So this would be while we have a node, a dependency. So this would be a command node. Guess you call it dep or something like that. So it's node dependencies, yep. So while dep, we do dep dot command, right? Links to that command. Sorry, dep node command dep equal dep next, yeah? Now, what we're also missing is the other way around. So we also need to make sure that, so if dep, sorry, if the node contains a creation, so if the file is created by another command, it's got one of these guys. So in that case, we shall have this thing that links to that thing. Hang on a minute. Sorry, I did the generation wrong for the one above, but we'll sort that out. Right, so this actually is incredibly wrong. It is... yeah, that's what it is. We put a new line on every one of these. And then we just do it one more time, but for the commands, right? So we look for file, command, then this is the commands linked to files, right? They have inputs and outputs. So we'll call it the inputs. So you just keep searching over all the inputs and just saying that so we'll call it dep node. Yeah, I think we might get duplicates if we did it this way. So if the files link to the dependencies, yeah, so if the files link to the commands link to the files, then like you only really need to do one of them theoretically, right? But I guess this is where you probably want a validation function before you call this print function. That checks for things. That's definitely something to do. But yeah, so I think this is what we want to do basically, is have... We'll get rid of the one above because it's just easier to do it this way. In, replace with out. Okay, so you've got your command, it outputs that dependency. So it's the other way around for this one, isn't it? Okay, easy. So this would be fun to test out, and then we can write a validation function as well, just to verify the DAG. So you'd run those in like a debug mode or whatever, and it would just dump these every single time something changes, which would be cool. But yeah, so let's try it out. So we're going to go here, and what would be cool is actually if it didn't do anything anymore. So we index the files. We now simply call this really nice command, which is command vk shader, and you put a filter in there. So you just go right code slash, and we could just use star star at this point. And we can now just say, hey, I want all of your GLSL files, right? Yeah, all of those. That's what I want to compile, right? And it's going to do that now. And it's going to build some kind of DAG. So then we can just say DAG dump. And that's all we really want to happen. Be cool. We've got to find... I think that's fine. Right, so does this build now? Right, we messed something up. Right, so all these commands here, we just get rid of this now. So we best to comment it out because I probably want to keep it to look at very soon. There's also parsing depth files and all this, which is very handy. So I definitely want to keep that. Right, 1536. So long. Oh, I've got to do all these. Give me a sec. Not very fun. Right, so alloc array. Unfortunately, I could do type of, but it's kind of a compiler extension. Well, commands can kind of go, actually. Timestamps, not so much. Whatever, let's just write it in. U64. Command process. So watch directory path. Char and the indexed files are a bunch of chars, aren't they? That's a string. Nice. Right, what's this one complain about? Oh, these are the DAG nodes and stuff. Right, so DAG file node. Add DAG command node. Alright, here we go. Command barrier. Okay, so build run. We need to comment that as well. Because trying to do stuff. Right, build watch. There's too much stuff commented out. Right, where's my build watch? It's right here actually, just above. Bring this back in a bit. Ooh, we're so close. Amazing. So apparently it ran. I don't know if it did or not, but sorry, ended successfully. But we should see a DAG dot. No, we don't. We've got a crash, but it's okay. So we can run the build script, see what happens. Okay, here we go. On the F close. Oh, it failed to open. Interesting. Oh, it's a read. Right, that was really bad. Whoopsie. So here we go. Watch this now. Come on. Oh, look at that. DAG dot open with. No. Okay. There were no nodes. Is that true? Like, why did that happen? So, you're telling me you found no... What GLSL files we got? Yeah, they're all there. So, something fishy's going on. Okay. So before the DAG dump, we must get here, right? No, this was working last time. What have you done? Right. Right, so does it match? What was it got in here? Build script, build. Oh, they're not big enough. Are they? Yeah, that's a bit bizarre. That's not big enough. Maybe, well, sorry, maybe... Yeah, I'm not sure what the 78 gets you to, obviously. That's interesting if... So when we index the first file, let's look at that. Here, right? Right, then they gets overwritten, I think. The memory gets trampled. What's going on in normalized path? Working fine the other day. We allocate a new string. Oh, it's here in it. Allocate a new string and copy it, yeah? We did change the alloc code, but still that should be... Ah, damn it. Whoopsie. Right, here we go. Let's try this one out. Shader name does not imply shader stage. Amazing. Right. So it does, but clearly the code is buggered up. So command vk shader. Here we go. So yeah, I think that includes the null terminator. That's the problem. So we did data plus size. So p data plus index p size take 3. That doesn't get you on the dot, does it? On an L. On an S. Yeah. Oh. Oh, yeah, because this used to be .spv, So, all right. I think that's what it was doing. It was defining the destination, whereas now we pass in the, rather than the output, we pass in the input. Right, then. So command vk. Does actually take 5. So, I think so. Let's try that. Ah, bizarre. Right, let's get in there again. And these people, eh? They never stop going at it. This debugger is a RAD debugger. It's available on Windows and it's coming to Linux, I think, quite soon. So yeah, I don't have to use Visual Studio then, which is pretty nice. It's somewhat new. It's been out a couple of years, I think. Yeah, so the null terminator is on size. So we did -1 that gets you an L, right? Yeah. -2, S, 3, L, 4, G, yep. Exactly. Oh, but GLSL, right, okay. So, oh, I get what I did now. Right, I need to give back another 3 more. So that's because it never used to include the extension. It was just the file name. Right. Oh, come on. Oh, then it's in a string compare. So it's 7. But then test 3. So that point it's in a mem. Okay. Oh, it's 8. Right out loud. Finally. Right, here we go. Look at that. Right, so this is the node graph. Now, the problem is, though, it's doing like paths and stuff. And I think this is going to cause us problems. So I think we need, and they're quite long. So we might be able to do file name. Yeah, some of the paths are like stupidly long. So what's the point of this? Are you talking about this file? So we're trying to debug a graph, basically. Do you want a bit more of a high level rundown? We're trying to currently just debug a graph for our build system. So basically the whole point is that we used to just, for the build system, define the stuff like this, right? Where you define the commands you want to run, then you put the barrier in there. So the barrier means basically run all the previous commands, wait till they complete, and then you carry on. But we need to, so there's two ways you can do stuff, right? We can do it as a single command buffer, basically, where the commands get ran. You wait until they're all done, then you carry on again. But then that only has one kind of one feed of commands, and you have to wait and completely let your threads drain until they're doing nothing. So by doing it as a graph, so this sort of DAG thing, then this means that essentially we have a full dependency tree of all of the commands, and we can, you can essentially, the barrier essentially goes on every node rather than on every node that has one dependency left. You can think of it that way. And so that means the streams of commands that could possibly run is multiple, right? So that means you should effectively keep your threads on your computer at maximum efficiency, basically, when it comes to scheduling them via when it comes to scheduling them commands, at least. So that's the reason why we're switching to a DAG, basically. So it's just a graph of nodes that are connected, basically, and you've got a bunch of input files, output files, and then commands that link to those input or output files. So yeah, I think we need to put some names. It would be nice to shorten these names, you know, this is quite... Yes, I think you want to resolve, so normalize, I think. Yes, I think when we normalize, I think we can do all that, but then we can say if string yeah, so that if g build dot Current working directory, is that? What type is that? Well, that should be a string. Okay. So we can then say if the string starts with, so that's just a simple, the size is greater than size here. And string n compare g build dot current working directory and the I guess you just compare. So if it starts with a current working directory, basically we can just get rid of that from the path. That can help out with quite a few things. Yeah, I wonder if I should make them all relative paths, to be honest. Nah. Because now the filter's not going to work. I think the filter's not going to want to use any current working directory anyway. What is this? Why is the build script.h being passed in? What's happened? Hmm. Right, I think it's saying that matches. Where is it gone now? Right, so it's actually matching a lot of these now. Match code is busted. Oh, I didn't even copy it in there, so it's just empty. Great. If relative, I'm not sure if we care about that anymore. Right, let's leave that for now. Damn it. Got a crash somewhere. So it would be cool to get... Oh. Right, now we've got no filter. Hmm. Right, so the indexed files. Why have these got the current working directory in them? So you've normalized the path. Clearly not working. So if that is less than or equal to size, there we go. That's why. Right, so open this graph, this dots file. Hmm. Wheel. Do more inspecting. Yeah, we need to go to that normalize. Right, let's go to locals. Well, not really locals, but right. Yeah, so up to the engine, yeah. So why? Yeah. EST. Yep, so that should boost it, right? No. Why? Compare. Right, I think we're included in the null terminator. That's why. So when we get the current working directory, no. Oh, it did move it. Ah, I missed the forward slash though. Oh, very nice. Here we go. Voila, much better. So this should now be able to be opened in some kind of graph viz dots visualizer. So you can get it to like render. Is this what we want to do? You can use the application, right, to get it to render to a PNG file. But I think they have viewers as well. I don't know. Yeah, let's do it. No. Yes, I think this is just command line programs, which is cool and everything, but like, on like, I can just dump it online though. So we could just do these, right? Okay, so what have we got? Does this work? Line 1. No. Yeah, so I think that's part of the issue, right? You can't do... So if I did a slash in there, is that a problem? Yeah. So if I put it as a string though... Right. There's the fix. See, it seems like... Alright. So we've got the string things there now. I wonder how well this will take to it. Right, so it needs that sort of prefix here, the digraph G, yeah? Unfortunately, we'd start with that. Yeah, it's much easier than printing out my own text file one, and we can actually view it visually. It's just, it'd be nice if we had a proper application. Because this kind of sucks, right? Right, so it's getting closer. The 139. Yeah, I'm viewing now. Oh no, that's too much work. Not tempted to do that in the slightest. Man, this sucks. Like, did it not? Did it really like fail to print out everything? Do we need to like do a flush? What close did that? Right, let's check it this time. It's still capping out. This is not good. It's capping out rather conveniently at 16,384 characters. Rather interesting. It seems like a power of 2 that I've put in my code base somewhere. But then like, this is not my code base. So is it just crashing? Dun-dun-dun. Alright, so Step node path. That's an interesting one. Yeah. It stopped on quite an interesting number, but maybe that was just random. Can't be though. Maybe it's Notepad rounding it up. Or maybe it wasn't a power of 2. Maybe it was off by a few, but it did look like it. Come on. Yeah, this is interesting. So one of the outputs is not anything for some reason. See if that works. Huh. Oh, it's failed to read memory, right? Oh, the node is null. Oh, we're not setting null. No, we are setting the node. Weird. So I don't know what's going on. I guess the pointers might be stable. So maybe. So what's the pointer, right? Right, there's the pointer. Does it stay the same? It slightly changes. But it's a F720. Hmm. What is the... Right, is it the downsample one every time? Right, it seems like it's the downsample one every single time. Why? Why is it the downsample? Yeah, so probably when we make the downsample, it's not actually a problem. So graphics bloom downsample. Right. So it was the well, we can make it we can just pick some, just put it there, see what happens. Fixed memory location, right? That might help us debug it because then we can watch it from the beginning. Let's try that. Right, does it change? No, it stays the same. Lovely. So we can actually put a watch here now. So you can add a address. I'll manually type it out because it's not allowing me to copy it. 1, 2, 3, 4, 5. 1, 2, 3. E F 720. Right, when we break on a right, please. And off we go. You ready? Let's go. We'll restart. The right memory location. It seems like it's never written to. You know? What about this node here? Command nodes input. Headless. Maybe they're not set to null by default, but it's zeroed memory. So like, right, so how are we making these nodes then? So it's a command. Yeah. Unless that it's definitely zero memory, so right, let's check this one. Yep. It's the address of this guy. Cool. So add a that's interesting. Yeah, this is not pointing to the right location. So this is the fixed memory address. This one's at 62 something or other, right? It's different. Oh, crap. Ah, I've accidentally pressed the wrong key. Okay, oh well. 0 is 1. 1, 2, 3. 4, 2. D0, let's go. Alright. Apparently, I was writing it here. Right, so it seems like what's going on is we're getting some memory corruption, basically. So we're allocating the same piece of memory twice, overlapping the memory. Big silly. How am I managing that? So the dep node here, this one. When we bump allocator, we're getting it to be the same as a file node, I think. Or a command node, one of the two. Oh, no, we're not. Right, so here we got set to dep, but we allocated it. Yeah, there's the one, see? Right. D0. Then why hit the breakpoint here again, though? Right, my issues with this. But yeah, right. Seems sensible to me. Oh, we're not aligning the memory. Damn it. Oh, no, we are. So, yeah. So aligned, then equals cursor plus size. That's a problem. Yep. Right, I think that's fixed it. And exit. Beautiful. Look at that. Right, here we go. Right, there we go. There's the graph. It's horrible. Super wide. But it's there. Right, so we just need a... better program basically. What's the best viewer on Windows? Hmm. Apparently 4 people. I've rated 5-star. Oh, it's an extension for VS Code, of course. Everything's an extension for VS Code, isn't it? I guess. Not a big fan of that though, but still. Kind of sucks. So all the VS Code one is going to do is probably use the command line app to render the PNG that renders the PNG inside VS Code. I'm pretty sure that's all this thing does. But at least we can view the text file directly in here actually, so I think it could be quite alright. So add you the viewer. Run out loud. Right, so Control-Shift-P. What do we do? There we go. No end. So that means the file doesn't exist, right? No entity. Have I got to close it open again? Go away, man. There we go. So yeah, it's similar as the one online. There you go. So yeah, so because these nodes don't actually connect to each other, they just have they're kind of like kind of flat. And it does go stupidly wide, which kind of sucks. So we could probably change some of these things. Maybe we should just call this node something else. Let's do that. So when we do a command node, so string name, that might help a bit better. So it's just a short name of the command. So then when we dump, we define it as a name. Ooh. Right. Can't do it that way. Graph is dots. So we want to define node with a duplicate name, visual name. So you can do a label. Yeah, so we'll still do command. We'll also have a label. Label equal okay. Let's try that. Oh, hang on. String C VK shader. There we go. So it's a little bit more manageable, right? It's less wide. But yeah, perhaps we can shorten these names as well, to be honest. Yeah, that's interesting. This loops around to itself for some reason. But yeah, there we go. So this will help us debug our graph. We can inspect the data and see where the issues are. We also need to write a function to validate the graph to make sure it makes sense before we print it, basically. Sorry, before we dump it. Yeah, this is cool. So I think for shaders, so even for these files, you know, maybe a full path is fine. But yeah, there we go. Awesome. Right, so this is a good place to put it. So tomorrow there will be a stream from 2 p.m. GMT +1. We'll carry on with this by making tons of different ones, right? We'll make one for, well, not tons, but, you know, like 5 of them, I think. So to compile C files to object files, to compile an object file into DLL, right? Stuff like that, and link it up. And because we are going to be using those ones. And then we'll add those as different nodes, and we'll have to have some form of dependencies as well. I have to figure out those things, and then it should actually look like a proper graph where things are connected, right? Cool. Anywho, right, so I have to get going now. But anyways, good time, guys. If you want to chat in the meantime, there's Discord. And thank you for everyone who's supporting the channel. Appreciate you all. You can support the channel over at the following link. And yeah, appreciate you all. I'll see you all tomorrow, hopefully. If not, I'll see you all on Sunday. All right, God bless you all. Bye-bye.